Welcome everyone to Ontology Summit 2020. Today is the 29th of April, 2020. And I am very pleased to introduce our speaker for today, Professor Krzysztof Janowicz, who's a professor for geographic information systems and geoinformatics in Santa Barbara. So I think we're going to have a really exciting meeting today, talking about the really cleverly named KnowWhereGraph. Krzysztof?
Sure. Can you all hear me?
Yes.
Great. That's, you have disabled slide sharing, so how will this work?
I haven't disabled it, just to give me a second.
So I get host disabled participant screen sharing.
Somebody changed this on me.
Oh, no worries.
Okay, try it again.
Okay, does this work for you?
There, it's working.
Okay, perfect. So first of all, thank you very much for having me in, this time without proper haircuts. I have been a regular both on listening in and presenting at the Ontology Forum at the summits. So this time I'm going to focus a little bit more on the application side of things, but please jump in and ask questions if you have particular questions about the ontologies or the underlying technologies. But I self would like to focus more on motivating what we are doing here, showing hopefully some new ideas and revisiting some of the classics that kept us busy over the many years. So I've been working on semantics for half my life by now. So sometimes I'm still getting caught by surprise, and I want to start with one of those cases. So I really had the feeling that I dropped the ball, so to speak, both as a geographic information scientist and also as a knowledge engineer some time ago when we had a very big fire here in Southern California called the Thomas Fire. At that time, it was the largest fire in the history of California. As things go these days with the droughts that we are having, there's already another fire last year that is by now the largest fire. But at that time, that was very dramatic, very traumatic to us. And many of us had to leave town due to the air quality, structures burned down, and so on and so forth. And here you have one of the representations of this fire burning on both the Santa Barbara County and Ventura County sites. What was even more catastrophic is that directly after the fires, because they happened very, very late in the season in December, we had our first very heavy rain event in the beginning of January. And when the rain hit the freshly burned soil, it caused a massive, massive landslide that killed more than 20 people, cut our highway to the south, and closed down our universities and so on and so forth. So due to both events, the fire and the landslide, for instance, our local economy also suffered greatly. So how does this relate to what I'm going to talk about today and me as a geographic information scientist? Well, if you look at how we communicate information like this, you see something like this. This is a map that has been displayed in a meeting just days, I believe 2 days, if I'm not mistaken, before the landslide, showing the burned areas on a map in a way that we call a vector, so a polygon. This red polygon here is the area that had just freshly burned. And then in blue, the areas where we expect runoff due to our watersheds, due to the terrain texture, and so on and so forth. As you can very clearly see, these are complex patterns of networks that run into each other. And of course, as you all know, towards the coast, where the water runs down the foothills and so forth, and our ravines, this will be the areas where most of the waters accumulate. But that's not what we communicated to the public. And I'm not trying to blame people. I think our local government did absolutely great here. I just want to point to a problem that I think is very common. So here's how this has been communicated using those red block-like structures for mandatory evacuation zones and the yellowish patches, polygons, for voluntary evacuations. And what really hit me hard is when days after this landslide happened, I read an article that quoted somebody who was like a liaison between the community and the government and the firefighters. And he evacuated despite being in one of those voluntary evacuation areas. And what he has to say is written down here. I'm not going to read it out, but what really matters for me is that what he said is that just being in one of those voluntary evacuation areas was a big deal for him. Clearly not for many of us, because we have been asked to evacuate, return, evacuate, return, evacuate, return for the fire for weeks. So many people in those voluntary areas, note how they are closer down the beach, right? Didn't evacuate. And what you also said is that those blocks that you see in there, those evacuation zones, they have their specific shape, namely in blocks, so that it's easy to communicate who is in a block and who's not, and that it's easy for the police to monitor these areas, because as this person said, after you force residents out of there, so to speak, you own the area, right? So what I'm trying to say here is the following. The way we think about scientific data, using remotely sensed information, using simulations, using numerical models, and the way we then communicate this information is quite different, not only in terms of the simplifications that we take, like those polygons, but also in terms of the semantics of those units, like whether it's a mandatory zone and then you believe you have to go by law, or whether it's a voluntary zone where you may believe, because we have been in such zones for many times here in Santa Barbara, that if you really feel you have to go, if you don't think you can handle it yourself, well, then go, right? But that's not what they mean, as you can clearly see from the text. They mean you are in danger, right? So it's an issue of information communication, and it's an issue of semantics. And as so often, it's an issue of that we are not drawing in insight, we are drawing in data. How do we translate the data to insights on the level of an individual? So what really hit me personally as a geographic information scientist is that my work is about complex methods of analysis, geovisualization, making fine-grained local analytics. And then when it comes to showing this to the public, we send around text messages. And if we don't send around text messages, we show maps with blocks. Each of those blocks is uniform, while the patches that emerged, and you will not be surprised if I return to the previous image here of the runoffs, are highly localized. One building may have survived untouched, and the very next building, closer to a ravine, for instance, was entirely destroyed, and people even lost their lives, right? So there's a big gap between data being ready for analysis by citizens that you can, take out your phone and ask your Apple Siri or whatever you're using, what is my personal risk? Do I have to evacuate, right? You're just getting a text message and the zone you are in. So let's also move a little bit further from this idea and the problems that it identifies to how we would put such data on a knowledge graph in general and be able to then talk about the semantics of mandatory versus voluntary evacuations and try to improve on facts like that those areas of evacuation are homogeneous, while in fact they have a lot of structure to them. So here's a map after the fact that shows not only the Thomas fire, that's the one I hope you can see my cursor over here, but also the fires through which we suffered as a community over the many past years. And while this is a map product, the underlying idea there is vectors, or more specifically, the idea is objects, namely that a fire is an event, but it has a border, namely the area that is burned, and we can identify this border, and then we can talk about properties, the overall area of land burned, the overall number of structures destroyed, the overall duration of said fire, and so on and so forth. And to a large degree, I would say we know how to put this into a knowledge graph, or in my specific case, linked data. We could use GeoSparkle, we could use Suite. Don't mean to toot my own horn here, but we could use SSN and SOSA, which are by now WCC and OGC recommendations. So we know how to handle information like this. and put this on a graph so that you can ask a query like, show me all areas that have burned in the last, let's say, 5 years, because most likely there's not enough vegetation fuel, so to speak, there for a new fire, but some areas that haven't burned, they may be affected next, right? So if you then look at how the fire was studied in the process, so not after the fact in mapping it out but seeing how it unfolds, you have remote sense information. This is what we call a raster product, and the underlying idea is called a field. So at every location in space-time, you can assign some attribute value like, you know, radiation or heat, or just even a binary value, whether this is a freshly burned area or not. And in this case, it's really not clear how you would take such remote sense imagery, or for instance, drone imagery, and put this into a knowledge graph. So certainly you can say you're going to have it as a binary leaf node, just say there is some image product about something, you can look at it here or there. But of course, then all those nice progress that we made over the years in reasoning or question answering are out of the window, right? So you can go the other extreme and say, I'm going to triplify, so translate into a knowledge graph format, pixel by pixel by pixel. And I hope you will agree with me, this is equally absurd, right? And then there's a large spectrum, like using one of those annotation ontologies that have been developed over the time. Again, using SSN or SOSA to say that this is a collection of observations and that you can model it this way. Using maybe some object recognition techniques or even semantic image parsing to delineate the fire or something like this, right? But it's not really clear how to do this and what of these many stages from, you know, absurdly deep triplification to no triplification at all really does the trick. So before going deeper into this example, let's take a look at a very different domain. And just as a warning, it's going to get a little bit crazy here, so stay with me for a second. So maybe you're following Musk or SpaceX and his other ideas closely. There are some things about specifically SpaceX that strike me as being very radically different. And one of those things, aside of, you know, the way how Musk runs his companies, what these companies do, how they bring disruption, this is not what I want to talk about. What I want to talk about is how they deal with information. So to date, most companies still keep the information hidden from others. The information is where they take their decisions, which informs their policies, which sets them aside from their competitors. So the deeper buried down in your own structure your decisions are, the better, so to speak, you are shielded against your competitors. But also, I think the more difficult it is for your own or for yourself, for your company in itself, to realize the potential of the data. So let's look at SpaceX. And here's a tweet that really hit me hard from a few months ago about SpaceX. And the people sending those tweets, I'm not going to say they are like you and me, but what I'm going to say is that they are citizens. They are, you know, they are not space engineers. They are not paid professionals. They are not agents at, you know, or data analysts at insurance companies. They are folks like you and me. So here's one of those tweets, and it says, SpaceX fleet vessel Go Discovery journey to port of Brownsville has paused at Fort Lauderdale. Very high winds and seas are expected the next several days in the Gulf of Mexico, placing cargo on the low-profile deck at risk from overwash. And then you see information from a system that tracks, IIS is its name, vessels on the ocean, telling you the name of the vessel, where it currently is, how fast it is traveling, and where it has been seen before. Then you see the object view, right? An individual vessel and the trajectory of the vessel. This may remind you, for instance, of the trajectory ontology that I have presented in this context a few years ago. Then you also see the image of the vessel with the actual cargo on top of it, so you can even make out what they are carrying. You forecast, this is what we call simulation or models outputs, namely field observations of wind and how wind direction and wind speed is going to change over the next days. So think about this for a little bit. You have a company that certainly has strong competitors like Boeing and so on. And you have information about every single ship they're using, the cargo that they are transporting. We know that their cargo is being held up due to winds. We know when those winds will disappear. We can project how much longer it will take this vessel to get somewhere versus what SpaceX may have originally planned for. Imagine you are one of their competitors, like Boeing. Boy, you really need to love this data, and that people like Booker Chica Gell, for instance, here, blasting this out all over the net, right? And then you see other footage as well. Also recall that by people like you and me. And what you can see there, it's a little bit small to see probably on your screen, is that you see a crane collapsing and dropping some heavy load very close to two workers. I hope maybe you can make them out. They are just jumping away. So boy, if you are the insurance company and you know that this happened when this accident happened in brief succession of another event, you may be thinking, maybe we should be reevaluating our policy. Maybe this company is moving too fast, right? So what I'm trying to say here is that we are living at an age where information, at least about companies that are willing to share or not trying to hide, is really unprecedented. And where you can combine data across vector data, field data, imagery, video, audio, interviews, whatever you like, observations from the sky, to gain really valuable insights, both as competitors and as insurance companies and many, many, many more players. So what these people are doing, so to speak, is that they're giving us unprecedented views into the inner working, like supply chains, disruptions, delays of a company that is, I think, very, very innovative. And on top of this, and this is what really strikes me about what they're doing, SpaceX doesn't mind, because all of this contributes not only also to their decision making, but to a big excitement and craze about how fast they are moving, and how, at least from my perspective as an outsider, I'm not a rocket engineer or space scientist, they are really revolutionizing the business. I think that's fair to say, right? So I'm quite impressed. So looking at this, I was reminded of an interesting idea that Heiko Paulheim had many years ago in 2012 for his award-winning Explain-O-LODI demo. You can call Explain-O-LODI a little bit naive if you know the tool, but keep in mind, this was an early idea by Heiko's, and I think it's really, really cool. So if you haven't seen it, let me walk you through this. Heiko's idea is like this. Very often in the news, you would see something like tabular information, just as we do with COVID right now, cases or even maybe people who died due to COVID, or crime indices, or indices of life expectancy, and so on and so forth. And you're thinking to yourself, I only see this table, country or city, and then cases, whether this is COVID, crime, life expectancy, in this case that you see in the graphic here from his work, I believe it's corruption. And you ask yourself, what's causing this? Why is country A dealing so well and country B maybe not? And of course, if you're a scientist, you have your own data sets to study this. Of course, you are limited to your own data sets, because when it comes to the data sets of others, as we all know, semantics becomes a major issue, and reusage of data. And I think we are still far away from this working at scale. So what Heiko suggested is that he takes the linked open data cloud at this stage, 2012. This was really a very, very new idea, specifically DBpedia. Then he looks at the table about the location, about the city or the state, does named entity recognition, fetches this recognized entity, cross-references it to linked open data, here specifically, for instance, DBpedia, and then takes the DBpedia knowledge graph to extract all the other information, elevation, area, crime, who's the mayor, everything you can possibly dream of. And then he creates simple, I would say, explanations. So for instance, just correlation between the data that he found and the data reported in the statistics. And then he also has some interesting work on more complex rules. And I think over the next years, Heiko really continued this work. So there's certainly way more than this 2012 paper. But the idea is quite, I believe, to this day. You have your specific local problem, and then you enrich with outside information, and hopefully this helps you to generate explanations for you, others, and even the general public. I know that Heiko was hit all day long with this causation and correlation are two very different concepts, but that's not really what neither he nor I am getting at. So imagine how this would work with the slide of SpaceX before, where suddenly to explain how this company is progressing, whether you should be buying stock of a company, you would have access to live video of accidents maybe happening there. You would have data about wind, about vessel positions, and so on to inform your decisions. I guess it goes without saying, if you would utilize these ideas, for instance, for commodity prices or something like this, you would really have a unique perspective on understanding things as they happen way before others do. So how crazy are Heiko's ideas, right? Is this just, a dream for a cool tech demo? And this is, of course, impossible to do on the scale, right? So let's look at the company who actually did this, namely Esri, a leading GIS company. And of course, they didn't solve the problem in a general case, but for a very specific case. But I think it's very important for lesson learned. So what Esri does there, and they call this the geo-enrichment service, they allow you to pick your own data, your own study area here, somewhere in the broad LA area, I believe, and then say, now reach out and find me demographic data about this region. Now reach out and find me, for instance, data about crime, or find me information about the landscape. And this is very, very powerful because you're not getting only very well curated data, you're also getting up-to-date data on demand, so you don't have to store this locally, and you're getting data that is already made fit to your specific area of study. I'm going to talk about this, I believe, on a slide or two. So in a nutshell, you are giving it your study area, and you're getting, and I highlighted this here in red, your study area back, but now infused or enriched with attributes from their own very well maintained internal, knowledge base, so to speak, of largely demographic factors. They have more in that they have a set of interesting data categories, but it's certainly not all encompassing. So here's an example about how this looks like. So for instance, and this is now an API call, not within your geographic information system, but you would say, what kind of data collections are there available about the US? And then you would get information like this, for instance, that you have population last time updated in 2017, and it goes in a 1-year age increments. And then you have the second step that I briefly mentioned, namely apportionment. The specific region that you are interested in, your study region, may be a highly complex polygon, like the footprint of the Thomas fire that I showed you before. So how would you match data to a region in space that isn't predefined? It's a very different problem from what Heiko originally considered for Heiko Paulheim in his named entity recognition, because this entity isn't yet there, so to speak. So Esri has a clever trick called data apportionment, where they take observations that are within your area and then basically do a weighted combination of this. I'm not going into the details here, but please ask questions if this is of interest to you. So what we are proposing is to take this idea and like supercharged or re-envision it and think, what if this wouldn't be about just tabular data? This is what you see here on the left and why I'm showing this. But it would be really open-ended graphed data. And what if this would be data that is not about well-curated categories from them, but really a knowledge graph about all data, in our case, at the human environment nexus, whether this is data about crops, about soil health, about droughts, about labor, and so on and so forth, right? And what about if we wouldn't immediately flatten the data into a tabular format once we import this, but we would allow the scientist or the analyst to traverse the graph from within a GIS or any other information systems. So what if you would radically re-envision this geo-enrichment idea by fusing it with something like linked data? What if you would take this geo-enrichment and the Explain-O-LODI and really fuse it into a cool system for knowledge engineering? Well, we played around with this a few years ago, 2 or 3 years ago, and published a paper about this like 1.5 years ago by now, where we asked the question, how can we ask queries that you can't answer with geo-enrichment? With geo-enrichment, you can talk about the population structure in your study area. But what if you would like to know about the regions in geographic space that have been studied by famous explorers who themselves were influenced from Humboldt, who is one of the most famous explorers, I guess that's fair to say, in history, right? You can't do a query like this in geo-enrichment in an S3 product because it traverses the graph, and multiple hops in this graph are not geographic. They are people or maybe even events, right? So you would go from find Alexander from Humboldt in a graph, find the people that he influenced, and then find the regions where they work, and then map the regions. And we developed a system. I can walk you through the slide later on if you like to, how to exactly do this by reaching out to a knowledge graph. In our case, we mostly relied on a Wikimedia and Wikidata, if I recall correctly, and then how to merge the attributes, how to deal with all sorts of issues in getting linked data into what is called a geodatabase, so one of the formats for a geographic information system. And then even cooler, do it in a way that we construct the schema for this geodatabase on the fly as we go, so that we can really follow and traverse the graph from within your GIS instead of just importing the data, having a table, having a geodatabase, and then do what you did before. Because quite honestly speaking, there are other technologies like web feature services and stuff like this that do this. So we create database files, geodatabase files, or data tables on demand, so to speak, and then really allow you to traverse them further and further and further. So here's one of the parts of the interface on the left, just to give you an idea about that this is really going to be a mess. You're loading in parts of a Wikidata, and they have this weird semantic issues and labeling, and then you have to fuse data, and then you have to come up with rules, and you have to decide about how you want to traverse for n degree hops, and which of those hops can be of different types. I am super, super excited about this research, but honestly, it has a long way to go from a research prototype to something that is really usable. And I'm so glad that we are working with S3 of actually making this thing a reality. So in this idea of supervising on putting geo-enrichment on steroids, where you would take a knowledge graph, again, in our case, we worry mostly about data at the human environment nexus, and then ask it to inform decision-making about supply chains, food security, even issues, for instance, in modeling of infectious diseases like COVID. I'm going to show you a slide about this later. Well, on the way to doing so, you have to revisit many of the problems that keep us and the Ontology community busy over many, many years. And the way we see the specific project is more of a one of technology transfer and knowing which of our technologies that you and me have developed over the last 20 years to really industrial strength application, and to really understand what is ready for prime time, how to integrate this, and what needs more work. So don't worry, even though the list that you're going to see is very ambitious, and I'm going to come back later, I'm not actually suggesting to solve the static interoperability problem. I leave this for the next 200 years of research. But what we are going to do, or what we suggest, is this kind of feature engineering or automatic feature suggestion to inform downstream models. So on the way of doing so, we of course have to deal with the issue of ontologies. And I personally, this from my previous talks here, I'm a believer in microtheories and ontology design patterns. So I believe that while S3 had their predefined, well-curated categories, for us to make a more open-ended geo-enrichment, we of course have to find the balance between everybody being able to express their beliefs and therefore their ontologies and ontological commitments in whatever suits their data. But we need some way of ensuring interoperability, and I believe ontology design patterns are a way to do this. We will also need to deal with ontology alignment, right? We need to make sure that on the T-box level, we are able to connect those ontologies so that we can really traverse this for geo-enrichment. And of course, we need to deal with co-reference in other communities. This goes by deduplication. So same as, so to speak, if you're an all-believer. And of course, in many cases, we are going to run into the issue that all of these sets are overlapping, so they may have the same attributes, but with different values for the entities, in our case, for instance, geographic entities. So inflation and stuff like this also appears high on the agenda. And then we have some things that I think are unique, like link prediction or multi-hop link prediction and knowledge graph summarization that I want to talk about in a second. And one thing that I'm particularly excited about in this context is that we also want to showcase And I think this is more generally in knowledge graph. I believe the biggest thing to keep them from being really impactful widely is spatial and temporal scoping, namely the simple fact that a certain statement is only true during a certain time. Think about COVID. Right now, most of us, I don't know where you are right now, but for instance, here in California, have to socially distance themselves. So this is like a statement in one of our ontologies and knowledge graphs. I can show you this in a second, but it's not going to hold forever, right? And then, of course, there are also other things. So that's the temporal scoping, where space or regions cause the scoping. So what constitutes an essential service differs by state. So if you're running a model that predicts how this is all going to play out and how important social distancing was while doing so, you better account for the fact that essential service has a very different semantics for each of the states. So meaning is scoped geographically. Very interesting stuff, as I'm sure you would agree. So one of the interesting things, and I'm not sure what caused the bubble to appear on my slide, the circle, oh, now it's gone, okay, whatever. That Heiko had to deal with is that when he fetched, this is the first part on top here, from this table that he wanted to enrich, the entity like Vancouver, for instance, he had to match this with DBpedia, right, or Wikidata, whatever you like, and then add all the attributes from Wikidata. In our case, that's substantially more complicated, but also very exciting from a research perspective. I'm showing here on the right is data, I believe, from yesterday or maybe even today in the morning. Yesterday, yes, about COVID cases in Santa Barbara County. And as you can see here, sometimes it's the city of Santa Barbara, and then we are good because we can easily match this in our knowledge graph, let's say GeoNames, Wikidata, Wikipedia, and so on and so forth. But in other cases, they group communities together, or they even prominently appears a prison in there, right? So for instance, you have areas like including municipalities of Montecito, Summerland, and Capital Rio. So how do you deal with the fact that there's no one-to-one correspondence? How do you deal with the fact that you need to come up with this idea of a region? So this clearly goes back to the question about how Esri, for instance, assigned to study areas, demographic data. How would you do this with graph data? Super exciting stuff. So one of our ways of thinking about this more generally also is knowledge graph summarization. There's some early work on this, not that much, but on geographic knowledge summarization, at least to what I found or we found last year, we were, this is the only paper ours that is out there currently about this topic. So if you make this open-ended enrichment, then as you saw from my screenshot before over, let me briefly jump, I know it doesn't work so well with Zoom, but as you see over here, and I'm happy to discuss this in detail later, you are getting hammered with information for New York alone. And just using one of these data sets alone, you're getting like 30,000 triples last time I checked, right? If you would conflate this and do our, human environment nexus knowledge graph for each of those places like LA, you would be hammered with data. That wouldn't be useful. So we need to come up with the task of identifying meaningful subgraphs that really matter. So this is a little bit like the data apportionment on steroids, so to speak, because we also have to deal with the fact that we may be talking about regions. So not just Santa Barbara, but Santa Barbara County or 3 cities being summarized together. And then, of course, we did this a little bit also predicting, the effects on COVID on the stock market for Apple, for instance, using n-degree hops from their supply chain. So where the products are manufactured, where there are lockdowns, or where people can't work like in Wuhan at that time and so on. And what was really painful is that you could model the entire supply chain, and then somewhere in the middle, there would be one relation that is simply missing from Wikidata or DBpedia. Surprisingly, it worked well in Wikidata, and there was one missing hop in DBpedia. So you need link prediction and maybe even a multi-hop link prediction to complete, or at least to fill in links in your otherwise sparse graph. And super interesting stuff. Check out our publication. I'm also happy to answer questions about this. So the entire project that I'm talking about here works in 2 phases. Phase 1, which we are just about to finish in the next days, and then phase 2, which we are just applying to. So please keep your fingers crossed that we will convince NSF and others that this is really interesting stuff, and we are going to get to do this. But for phase one, what we did is we did a lot of interviews. We worked closely together with many domain experts, for instance, in commodity trading and soil health and so on and so forth, to see how we can inform their downstream models. So we are not the ones doing modeling. We are saying that our enhanced geo-enrichment, our supercharged geo-enrichment, are supposed to provide potentially explanatory features like independent variables from the graph in real time that those companies don't have to maintain, right? And see how can we really engineer meaningful features out of this. Keep in mind for the Googles or the Apples, that's not their challenge. They know how to do this. But most smaller companies or not so super tech-savvy companies, they would greatly benefit from open access to such an open knowledge network where they can mine features that are always up to date from different domains, readily conflated. They understand their semantics and so on. So long story short, we did a couple of these experiments in phase one, just rapid prototyping and see, we are basically throwing ideas at our industry partners and see what will stick, what will they like. So one of the ideas we had here is, what if you would have a user interface like the one developed here by my student Eng Cheng, where you would allow people to load in their simulation data or remote sense information. Here it's a prediction of fire likelihood in the greater Los Angeles area. So information, for instance, from the sky, and you would enable them to enrich this on the fly with things that they don't see from the sky, like, for instance, which events took place there, where are the fires that were in this area before, or are there schools in the region that is marked here, for instance, as high likelihood of fire. And then we implemented this. We showed this as a demo around. I can share the link. It's actually still working. Here you see me loading in such a fire likelihood layer, and then you see me, I think I selected oil fields that may be in this region, and then further down I also selected an event layer, namely about previous disasters. I forgot exactly what I did there. But the idea is exactly this: enrich data that remote sense data from the sky with event data from a knowledge graph, for instance. What we also did is we did the same idea just the other way around and followed a system that you may know, OpenCalais. They changed their name recently, but I think they have a phenomenal idea, namely that you ingest text data like the news, and then they highlight all the people, all the industry mentioned there, all the themes, and then you can follow the internal graph, so to speak, to contextualize this information, to learn more about this. And it is my understanding that they are now heavily used by, for instance, news organizations. But they're not so good in first place name disambiguation. We have some work that shows how we can do very good there from 2014, I believe, or 16, sorry, presented at AKAW. And they're also not good at regions. So everything is a single point, so to speak. There's no idea that if multiple places appear, they are somehow related. So what we did here, and you again see our early demo, and now I just took a Washington Post article just from today to make sure you see that I'm not cheating, just copied it in there, and down there you see our tool catching all the people, institutions, geographic regions, events like the Olympics, and then you can click on them, you get some data from the knowledge graph, and of course you can then click on this and in this case reach out to Wikidata. And where we really want to take this is take this to this idea of a region, right? So that in an interconnected world, just understanding regions by the point locations is meaningless. By the way, I believe that this is a very serious problem still in analysis of the COVID outbreak, that we are not considering the neighborhood effects. We are talking about, is Sweden doing well because it's maybe not socially distancing, totally forgetting that all its neighbors are very clearly socially distancing, locking borders and so on and so forth, which very clearly contributes to the effects that Sweden is seeing and so on. Another issue that we identified is that at the end of the day, what makes knowledge graphs so radically different is that they are not search engines for data sets. We have this. This is NSF EarthCube. This is Google's new data set search. This is, Data One and many fabulous products. What knowledge graphs should be about is data level or, observation level statements that are also AI ready. So ready for, that kind of question answering technologies and so on and so forth. So how can we assist decision makers, in this case, people, data analysts, people working in companies that are very small or very big, in understanding how data ready is your actual data, right? You have data that is in the heads of people mostly. You have data, and let's be frank, most of the data today, most of the decisions made today are in, Excel spreadsheets, right? So how would you know how data or knowledge graph ready is your data, and what are the steps that you would take? So we developed like an interactive tool. It's of course only an early prototype, and we ran this through with our industry partners, and in fact a few other projects that are also in this phase 1 to see whether this would be useful for them. And I think it's a really cool exercise. Again, this is an online demo. I'm happy to provide the link. Check it out. So what makes me quite optimistic that this is really a doable exercise, all the things that I'm talking about, is that when COVID broke out, I was a little bit sick in January, so I was basically hanging out at home, and I was monitoring the early stages of COVID, and thought to myself, boy, I've never seen something like this, especially the closures of airports, canceling all travel and so on. So we decided with my research lab to start to model this late January as a knowledge graph. And then luckily we were able to, just a few weeks ago, write an NSF rapid proposal to continue our work. And what we focused on here is not the usual things like, we also have the cases, you see them here, but focus on where are social distancing measures in place? When have they been put in place? What do they entail, those social distancing measures? What are the transportation routes that have been disrupted? Which flights have been canceled? What are the supply chain disruptions? Which local events are canceled? And to make this all highly local for geographic analysis, not going to lie to you, this is all in a very early, messy stage, and we are changing things for my students on a daily basis. But we as a semantic web, we as a knowledge graphing and ontology community, we have come a long way. I liked Mike Ushal's talk in this Ontology Summit a few weeks ago, where he makes, I believe, the same case. A lot of what we have been doing over the past 20 years, it's getting ready for prime time. We were able to spin up our knowledge graph, get data, triplify it, visualize it here using GraphDB, thanks for their license donation, by the way, in a matter of days, right? Which I think, that's very different from if I would have given the talk 10 years ago. Last slide, I think I'm over time. So what's our vision in a nutshell? Well, we believe that space and time matter not only for the obvious reason that, everything is somewhere, but because understanding where and when something happens is key. It's really crucial to understanding why it happened or why it will happen. So space, geographic space, is a great integrator in itself. And we would like to present this, supercharged vision, this highly enabled or G-enrichment plus component, where you can take your local domain problem, and in our case, this is downstream models in food security, commodity pricing, environmental policy making, and so forth, from our industry and nonprofit partners and government partners, and give them an access not only to the pre-selected themes, like for instance of S3's geo-enrichment, but open-ended, voluntary contributed, cross-domain knowledge graph data. And I think that's a very exciting thing. Ultimately, what we want to show, and I think this is a major roadblock from what I see working with the industry in really adopting knowledge graphs, is what we want to demonstrate is not so much that this graph is useful for just like open-ended traversal, but how can you mine predictive features for further downstream models, whether they are simple regressions or fancy machine learning, that will inform their particular problems like commodity pricing. And I guess that's everything I had to say. Sorry for running a little bit long, and I hope that was interesting for you.
Yeah, it was very interesting. Yeah, thanks.
Thank you so much.
Thanks, Krzysztof. Now, let's see if we have any. Todd has his hand up. Todd?
Hello, Krzysztof. Thank you for your talk. I have 3 questions. I'll try and keep them short. The first one, in your use of the notion of knowledge graph, does that include reasoning?
Oh, absolutely, yes. This is a fabulous question. Thank you so much for asking. Do you want to go all the 3 first, or should I take it one at a time?
Well, no, that's what I want to know first, whether your notion of knowledge graph include reasoning. Thank you. Yep. The next one had to do with analysis. What sort of analysis paradigm do you use for your development of ontologies?
Okay, so first, for me, there are knowledge graph as a multi-graph that is node and edge labeled does include reasoning in a sense that we want to have semantic descriptions of what's in the knowledge graph, and then we can use Shackle or OWL or whatever is your preferred flavor to do some reasoning. But we're also heavily into representation learning and knowledge graph embeddings and how to use this for reasoning, so for link prediction. And I guess this relates to your analysis question. So
no.
Okay, so you're making
when you're creating or when you're deciding whether a notion should be included in your ontology, are there any particular analysis paradigms or procedures you're using to decide how this notion should be represented?
Oh, sure. Yes. Thank you very much. So I'm a big believer in ontology design patterns, as I said, so in modular ontology design. And then what we typically do with our domain experts, and we've been doing this for many years, is competency questions. And I believe nothing beats that you are sitting down with domain experts and you ask them, what would you like to know from your data? Because this helps you understand the granularity at which you need to make your ontological commitments. You can certainly dive, take a deep dive, but the deeper you dive into your axiomatization, the more I believe you're hindering reuse by others. So this opportunistic reuse that we are trying to foster here. So what we have been doing in the past is come together with domain experts, ask them what kind of questions they would like to know, like the competency questions, run those as, pen and paper Sparkle queries, so to speak, and then say, this is what you could be saying, and this is what you would not be able to distinguish at this stage, and would you need further axiomatization.
Okay, and my last question was sort of a follow-on to the analysis question. How do you expect, or how do you do alignment among different or ontologies developed by different groups?
Okay, that's a fabulous question. So ontology alignment is one of the core working areas of my friend Pascal, who is also working on the project. If he is on the call, then I think he can unmute himself and maybe comment to this. But there are many technologies, from Agreement Maker to the Alignment API to Pascal's work on, I forgot the name, something with Boost. I'm sorry, I'm blinking about the names of Pascal's system. So there are many existing technologies that we can be using here and reusing here. And I believe that there's also a unique chance to combine the classical work in ontology alignment with work in representation learning and, for instance, similarities as measured between embedding representations of nodes and graphs.
So your notion of alignment does not necessarily include ontological alignment, or is that just an...
Oh, it absolutely does include. So there are two things. Let me go back to the slide. So I believe that there are multiple ways. First of all, the need for alignment is there because I believe that there shouldn't be like a one ontology to rule them all. Clearly, this is not the way to get buy-in from the industry, from many partners. We have partners that span from soil all the way to historic slave trade. So we are believing in ontology design patterns, for instance. Or if you want to relate things like, the spatial temporal scope, even microtheories. And then there are two questions to solve. Two issues to solve. The co-resolution question, so that two entities in two different knowledge graphs are the same, and the ontology alignment problem, which is the problem about whether two terms used in these graphs mean the same. And this problem can be tackled by many of those. There are probabilistic ontology alignment measures. There are ones that work very on the structural basis, so on the structure of the graph, and using, for instance, even very primitive things like edit distance. So there's a wealth of tools that we are going to try. There's some new ideas that I think Pascal should be commenting on if he's on the call. And then there, of course, is also the entire idea of learning those mappings.
Thank you. That's all I have.
There's an excitement paper. If one of my students is on the call, maybe you can type this into the chat. There's a really interesting paper about these issues from Amazon. I haven't thought about that. That would be a big problem for them, but it's also a big problem for them. So if one of you could type this, the deduplication work that they're doing there across graphs, that would be great.
If you want to unmute yourself.
Hello. Can you hear me?
Yes.
Yes.
Hello.
We seem to have an echo, though.
Hello.
I can hear you. Yes, go on.
Hello.
Ravi may not be receiving audio.
Can you hear me?
Yes, we do.
With a little echo, but can you hear me? Hello?
Ravi, we hear you.
Oh, good. I don't know how to say the speaker's first name. Krzysztof?
Krzysztof, yes.
Krzysztof, how do you know which are good filters? For example, you mentioned language, and you also mentioned events, other ground truth data, which you want to supplement to your basic image to make it graph ready.
What I believe you asked, and there was a strong echo, so please correct me if I'm not answering a question but commenting on something else, is you said something, what would go first? I'm not sure what you meant there in the context of events, but then you also said graph ready. So let me pick up on this first. So there are multiple issues here. Some of the data we already have in knowledge graphs, like the general purpose graphs, like Wikidata, DBpedia, more specific graphs, like we took, for instance, USGS, national maps, geographic names, information systems, so all the place names from the US, we put them in graph form and so on and so forth. I mentioned that there's a data set by our partner Matrix who has their historic slave trade data in graph form. So that's existing data. But a lot of our partners, and especially the partners that we hope to have in this on the long term, they realize that knowledge graphs are an interesting thing. They would like to either have their data in this graph, or they would like to keep their data, as part of their business, internal business data, but reach out to this graph to utilize the knowledge graph enrichment. So they would need to know which steps would they have to take to make their own data graph ready. And we have developed this little tool for them, which helps them along the way by asking like yes or no questions, like, is your data digital? Do you have data only in metadata about this in digital format? Do you have a schema? Is your data structured? If you have a schema, is it represented in a language like OWL or Checkr or something else? Or is it just a textual description or just a comma separated value file? Are you willing to share your data? You just go the entire stack down, and at the end you reach different data readiness levels. And at each level we would tell you by example, what can you already do and what can't you yet do? And at the end we hope that decision makers or companies can run through this online tool themselves and then say, this is the data that we are going to prioritize. This is our data that is first going to be connected to a graph, right? Because keep in mind, at the end, there's no cheating here. This will need work of knowledge engineers also for the vocabulary. So I'm not so concerned about systems like Any2Triple or something like this that lift the data to the graph, but more on the vocabulary side, frankly speaking. Is this answering your question, or did I get it wrong?
Thank you.
Thank you so much.
Okay, Gary, you're next.
Hello, Jano. Good to see you virtually.
Let's see.
I hope your family as well.
Yes, we're lacking a haircut, but all is good otherwise.
Yeah, I noticed that. So I had a question an open-ended question along the same line. So you might have covered a bit of it. I know you've been interested in rich data, and in your slides you mentioned AI-ready data as part of the graph as opposed to just searching for data. And I was wondering, and to some extent you started answering this already, what recommendations you might have, say for information that's coming out of the SARS-2 COVID area, what types of additional information or metadata about the data you might be interested in, and maybe getting people to move on so that could help build better knowledge graphs for this particular problem?
Thank you so much for asking. This is a really great question. And this is a recorded session, if I understand correctly, and maybe it ends up somewhere in the hands of others years later. So let me be very clear about this. I'm not a medical professional, and in my answer, I'm not going to provide any medical experience. I'm a data integrator. So what we did is we asked ourselves, clearly in this very first stage of the pandemic that we are still in, this is the time for the numerical modelers and the people who are working on spreads of infectious diseases. But if this is really a multi-wave, multi-year, multi-stage process, and most likely it is, we will need to hear from other voices very soon, the voices of those modelers that talk about those disease models. They have to, step down to make room for people who talk about other problems. And this will be problems of social justice. This will be problems of supply chains. This will be problems about our local economies. This will be problems about how do we envision the future of work now that we discovered that at least some of us, at least sometimes, can work from home. And what does this do, to traffic and to climate and so on. So if you are further down this chain and you have to make a decision whether you're going to throw away your tens of thousands of eggs, as some of the farmers said, or whether you have to increase your productions, as if you're in the business of producing flour, yeast, or toiletries, right? So you would need to understand which states have social distancing measures. Where can you import and what can you import? Which factories are currently still producing and which are not? What counts as an essential service? How is your demand going to drop, whether you're more, delivering to retailers or more delivering to restaurants and so on and so forth? So what we wanted to do is we wanted to provide data that others can use, have information ready at their fingertips for feature extraction for the downstream models, especially with focus on supply chain disruptions and more specifically in the agri-food system, so to speak. And therefore we focused on data layers that I think others have not yet focused on, like local events, highly regional data, transportation disruptions, differences in social distancing measures. And what I saw there, and again, please keep in mind, I have no medical advice to share, was really scary when I see what's being reported there, when I read some of the FAQs about some of these models that we are seeing published there. They are certainly very strong in the mathematical modeling on an abstract basis, but people are not dots in an empty Cartesian plane, right? So if you don't understand the semantics of all these different things, then I'm not sure how useful your contributions will be on the long term. Obviously, telling us that we have to keep social distance, which I agree that they need our work for, but further down the food chain of these problems, you will need to talk about these local differences, and you will need to hear other voices from politics about social justice. Why is it, if you look at our table, that our wealthy communities in Santa Barbara are not affected, and communities to the west, prisons are so heavily hit, right? So if you are not going shopping, but that somebody from Instacart do this, you're just reducing your risk by increasing somebody else's risk. This is a very highly cross-domain, multi-faceted problem, and we believe that a knowledge graph that is so, where cross-domain is one of the things that us have been working on for so many years, is a unique chance to hear other voices, lifting the data to a format that by being AI ready is ready for decision making. Okay, that was a long answer. I'm sorry, Gary. Where I'm going?
That was fine. I just note along the way, supply chain introduces the ideas you normally hear in manufacturing. It's another area now related to food and other things like that.
Yes, absolutely. Yes, that's exactly what we are doing with our industry partners. This is their bread and butter business. Like from Oliver Wayne, who is one of our partners. We want to supply features for them. They do the domain modeling. This is this is their business for a very long time. Thanks for getting trying.
Hey, Gary, you're finished? All right, well, no one else has their hand up, and we have reached the end of the hour. So I'd like to thank Krzysztof for a really very thought-provoking presentation. And I would like to invite everyone to come to the next summit meeting next week when Ernest Davis will be speaking. And all right.
Okay.
So Krzysztof.
Thank you so much. Thank you so much for inviting me. Thank you so much. I know that you're busy with so many Zoom sessions, so thanks for giving me the chance. And to speak here.
Well, it was a real pleasure to have you here. And thank you very much. And please join us at the at our summit whenever you have a chance and participate. And thanks to all of the people who gave questions. And I guess you weren't on the chat, but there was quite a lively discussion on the chat as well.